So we will discuss the next topic in kinematics, that is projectile motion in this class. Projectile motion means, suppose if an object or a body is projected with some velocity on a ground or on a horizontal plane or inclined plane, so its projectile will be something like this. So we can see, afterwards we can prove that this projectile will take the shape of a parabola. So this is called as the projectile. An object is thrown from this point, and after reaching certain height, so it once again comes back to the ground level. So this AD is called as the range or horizontal range, and this maximum height that projectile reaches, so is denoted by small h. I will take this as c, and the velocity with which the projectile is projected. So if you draw a tangent, so that the tangent direction shows the velocity, that u is the velocity with which the projectile is projected or thrown. Now here, this, let us take this angle as alpha. So this alpha is called as the angle of projection. So these are the things we have to keep in mind. So I will take here this path traced by the projectile is called as the trajectory. This is called as trajectory. So u is the velocity of projection. Velocity of projection. Alpha is the angle of projection. Angle of projection. R is the range or maximum range, you can say. H is the maximum height. Maximum height that projectile has taken. One thing here is, you can see that the trajectory is a curve. So as already told, this trajectory we can prove that it is a parabola. We will prove that later. So this, since it consists of an inclined projection with some angle alpha, this velocity u will have two components. The first component is the horizontal component. If alpha is the angle, so this is u cos alpha. Second component is vertical component, u sin alpha. So u cos alpha is the horizontal component of velocity of projection. U sin alpha is the vertical component of the velocity of projection. So in this case, we have to consider two motions here. Since it is inclined like this, and since this is alpha, this is u cos alpha, whatever I have shown there, u sin alpha. So it has both horizontal motion as well as vertical motion. So this projectile will have both horizontal motion as well as vertical motion. Vertical motion will give this h here, horizontal motion will give this r. So here, horizontal motion we have to take like this. Horizontal component of velocity, horizontal component of velocity is u cos alpha. Suppose if I take the time taken by the projectile is t, so the t is called as the time of flight. Time of flight. Time of flight means it's the time during which the projectile will be in motion. So if you multiply these two, you are going to get the horizontal distance equation. So S is the horizontal distance traveled. Horizontal distance traveled by the projectile. And since t is the time of flight, so u cos alpha is the horizontal velocity, this horizontal velocity multiplied by time will give the value of that s. So s is the horizontal distance traveled by the projectile. So you can see here this s is nothing but r. S is nothing but r. This is the horizontal distance traveled by the projectile, that is from A to B. So I can write here r is equal to u cos alpha multiplied by. So this is one equation. This is the horizontal motion equation. Now considering the vertical motion of projectile. So let me consider from A to C. A to C is the vertical motion. Distance traveled here is h. Please note that vertical distance traveled is h. Since it is traveling like this against the gravity, so we have to take g value minus 10.81 meter per second square. So that whatever equations of motion, gravitational motion, that will be considered here. So s is equal to ut minus half dt square. This is the equation we have to use, minus because it is thrown vertically upwards against the gravity. Now here, in this case, this s is nothing but h now. So please note that s is equal to h for the vertical motion. So u becomes u cos alpha, u sin alpha, because u sin alpha is the vertical component, into t1 I will take because it is from here to here. Next, minus half into g into u square. So this is the t1 is the time taken by the projectile to travel from A to C. From A to C, t is the total time. T is the total time taken. So this is the vertical motion equation. Now, if you use this equation, so I can write h is equal to, u sin alpha times t1 minus half into g into t1 square. So this is the vertical motion equation. So this is horizontal motion equation. This is vertical motion equation. So like this, we have to consider two motions of the projectile. One is in the horizontal direction, another one is the vertical direction. So the combined motion is the inclined motion. Now we can, using these concepts, we can always derive the equation for this trajectory. Trajectory is the path traced by the projectile. So like this. So you can always derive the equation of trajectory. The equation of trajectory. Trajectory is the it is the path traced by the projectile. Let us see how we can derive the trajectory equation. I will consider a point P somewhere here on the trajectory. The distance from here to here, it is x, and the distance from here to here is y. So if I take a point px comma y, a point on the trajectory, so wherein x is this distance, y is this distance, p is any point on the trajectory. Now let us see what is the equation we can use for the vertical motion. So vertical motion, now what I will do is, I will take the motion from A to P. So from A to P, vertical motion I am going to take. So if I take vertical motion from A to P, so this is the equation which I have to use. So h is equal to, h becomes y now, u sin alpha into t minus half dt square. So t I will take in general. So t is the time taken to travel from A to P. Now if I take the equation, h becomes y now. So this equation now, so if I take this as 1 and 2, so the equation 1 becomes now, equation 2 becomes equation 2 becomes, now h becomes y now, because I have taken the motion from A to B. H becomes y. Y is equal to u sin alpha remains same, vertical velocity, multiplied by, take t as the time instead of t1, minus half t square. So t becomes t1 becomes t, so half gt square. Now you know that if I take the horizontal motion from A to B, or horizontal motion from A to B, well, not A to B, A to P, so distance travelled will be x. X is the distance travelled, horizontal distance travelled from A to B. Velocity is u cos alpha, horizontal component of velocity, into same time t. T remains same. Now from this, t will be equal to x divided by u cos alpha. So this is what you are going to get, x divided by u cos alpha. Now I will take this equation as 3, substituting for t in equation 3. Now what happens, y is equal to u sin alpha into t is x divided by u cos alpha minus half into g into x divided by u cos alpha whole square, that is t square. Now if you simplify this, you will get y is equal to, so the sin alpha divided by cos alpha becomes tan alpha, u and u will get cancelled. Okay, u and u will get cancelled. So you will be left with now x into tan alpha. X into tan alpha minus half g into x square divided by u square cos square alpha. So like this we are going to get. Now 1 by cos square alpha can be written as secant square alpha. Now let us continue that. So equation we can still further simplify. So y is equal to, now I will continue that, y is equal to x tan alpha minus half, or I can write dx square divided by 2u square into secant square alpha, because we know that 1 by cos square alpha is secant square alpha. And once again, the secant square alpha can be written as 1 plus tan square alpha. So all these trigonometric relations you should be knowing. Secant square alpha is 1 plus tan square alpha. Now you can see, you can observe this equation. If you see this equation, you have y term in the LHS and x square term in the RHS. X square term in the RHS. That means if one either LHS or RHS contains one square term on the other side, if it is a linear term, then it is the equation of a parabola. So this is a parabola equation. So that means the trajectory, so I can take this as equation 4. Trajectory of a projectile is nothing but a parabola. So y is equal to x tan alpha minus gx square divided by 2u square into 1 plus tan square alpha. So this is the standard equation for the trajectory. So which is applied, which can be applied from A to B. Any point along this trajectory, this equation holds good. So you can see here x and y are the variables, alpha and u they are the constants. Alpha is the angle of projection, u is the velocity of projection. So for a given angle of projection and velocity of projection, for different values of x and y, you can plot that curve, that is the parabola curve. Now from this equation, we can find out the things. What are the things? We can find out this maximum range, maximum height, and time flight. All those things we can calculate. Now we will see how we can compute those things. So first, let us find out maximum height reached by the projectile during motion. So maximum height is given by, so that equation h is equal to u sin alpha into t1 minus half into g into t1 square. So similarly, you can find out the time required to reach the maximum height, that is T1 value. T1 is the time required to reach the maximum height. So all those things. So first one by one we will go. So first let us find out the maximum height reached by the projectile, that is h value. How to find h value we will see now. So to find h value, what we have to do is we have to take the vertical motion of the projectile. Vertical motion of the projectile from A to C. So A to C I have to consider. So you can see initial velocity, that means when the projectile is thrown from the point A, that is your initial velocity. Initial velocity is u now. Since I am considering vertical velocity, I have to take u sin alpha. So u sin alpha is the initial velocity. Final velocity will be 0 because when it reaches the point C, its velocity becomes 0. So final velocity is equal to 0. Final velocity is 0. Initial velocity is u sin alpha. Now we have to use the equation of motion. So here I will use this equation. V square is equal to u square plus 2as. So this is the third equation of motion. The thing is here, A is nothing. A is replaced by G. A is replaced by G. Of course, since your initial velocity is more, final velocity is 0, I can take it as minus. So that means the equation reduces to now V is the final velocity. This is V now. This is u now in this equation. So 0 is equal to u square sin square alpha minus 2g into h. So h is the distance traveled in the vertical direction. So therefore h is equal to, according to this, h is equal to u square sin square alpha divided by 2g. So this is the first equation. So which gives the maximum height reached by the projectile. So that is at the point C. This distance from the horizontal plane or from the plane of projection, the maximum height reached by the projectile is u square sin square alpha by 2g. That means it depends only on the values of u and alpha. If you know the velocity of projection and angle of projection, we can compute the maximum height reached by the projectile. Next is time required to reach the maximum height, that is T1. I have written this equation. This is the vertical motion of the projectile equation. Now we will find out the T1 now. So T1 is the time taken by the projectile to reach the maximum height. So I will write that now. So let us see how we can find out that T1. So T1 is the time taken by the projectile to reach the maximum height. Now, for that also I have to consider one of the equations of gravitational motion. So this equation I will take now. V is equal to u minus dt. So this is against the gravity. So that's why minus I have to take. Once again, V is replaced by 0. Final velocity is 0. Initial velocity is u sin alpha minus T1. T is replaced by T1. But that because that is the time taken from by the projectile to travel from A to C in the vertical direction. So therefore, D1 is equal to u sin T1 is equal to u sin alpha divided by G. See, this is another equation which gives the time of flight from A to C, not the total time of flight. So it is only from A to C. So T1 is equal to u sin alpha by G. So once again, this also depends on only u and alpha. If you know u and alpha, you can find out the time taken by the projectile to reach the maximum height. Now we will calculate the time of flight. Third one is time of flight. Time of flight means that is t. I call it as t. Now this is to travel from A to B. Total time of flight. Now this can be obtained by considering the equation of trajectory. So y is equal to, we have this equation of trajectory parabolic equation. Y is equal to x tan alpha minus, here only I have written gx square divided by 2u square into 1 plus L square alpha. So this is the equation we have. Now here this equation can be revised now. So this equation can be revised. Of course, okay, you can do in another way also. We will consider, I will do one thing. I will take the vertical motion equation as well as the horizontal motion equation. Then we will see. So what is the vertical motion equation? So vertical motion equation. The thing is, I am taking from vertical motion equation I am taking from A to B. Totally I will take A to C I will take first. Okay. So if I take from A to C or A to B, so here what happens here is, you should be careful here. So the distance traveled is I will take from A to P. Sorry, A to P. So distance traveled is y. The vertical motion distance traveled is y. This equation, of course, I have used somewhere else earlier also. So this y is equal to ut, that is u sin alpha, because I am taking vertical motion, u sin alpha into t minus half dt square. So this is the equation I have to use now. Now what happens at the end of the flight, this y becomes 0. At the end of flight, y becomes 0. What the end means? At B what happens? So it travels like this is x direction, this is y direction. At the end of the flight means at the point B. At the point where B reaches the ground, the value of y at B will be 0. The value of x at B will be equal to r. So this coordinates of B will be r, 0. Okay. Now, so if you substitute this value here, y becomes 0 here. So what happens? The equation reduces to now 0 is equal to u sin alpha into t minus half gt square. So you are going to get an equation of this kind. Now here this can be written as t. If I take common here, 0 is equal to t into u sin alpha minus half gt. So since the LHS is 0, this is product of two quantities. Either t should be 0 or this should be 0. That is u sin alpha minus half dt square will be 0. So please note that in this equation t remains same. So t is the total time of flight we have to take, because I am taking the point B. For the particle to reach B, it has taken the time total t. So the time of flight it has taken. So either this should be 0 or this should be 0. So t is equal to 0 corresponds to point A, initial point. Whereas this, if you simplify, so you will get half dt is equal to u sin alpha, or t is equal to 2u sin alpha by g. See, this is what you are going to get. This equation you explicitly have to remember. So total time of flight of the projectile is 2u sin alpha by g. Now if you observe t1 and t, so please note that t1 is the time taken by the projectile to travel from A to C, where t is the time taken by the projectile to travel from A to B. So if you observe these two, you can see that t is 2 times t1. So if you observe the two equations, we get t is equal to 2 times t1. That means what we can say here is the total time of flight will be equal to 2 times the time of flight between the points A to C. That means whatever point it has taken, whatever time it has taken to travel from A to C, same time it has taken to travel from C to B. So if you know one thing, you can find out another thing. Suppose if this is 10 seconds from here to here, total time will be 20 seconds. 10 plus 10, 20 seconds. So this is the relationship between T1 and T. So if you are asked to find the time taken to reach the maximum height, it is u sin alpha by g. If you are asked to find time of flight, it is 2 times of that is 2u sin alpha by g. Now you can always calculate this range, horizontal range, or simply it is called as range, using the horizontal motion. So initially itself I have given you the equation of horizontal motion of the projectile. So it is given by, if you consider the horizontal motion of the projectile, horizontal motion. So then you are going to get the horizontal range. Of course, here you have to take the motion from A to B, but it is horizontal motion from A to B. So distance traveled in this case is r. R is equal to, distance is equal to, I can write velocity into time. So velocity you have to take horizontal velocity, that is u cos alpha, into time taken is time of flight, because I am taking the entire from A to B, time taken will be t. Now substitute for t from this equation. So substituting for t from this equation, so what you will get, r is equal to u cos alpha into 2u sin alpha divided by g. Or in other words, r is equal to, you can write 2 sin alpha into cos alpha. 2 sin alpha into cos alpha is sin 2 alpha. So it becomes u square sin 2 alpha by g. So this is the expression for the horizontal range, or simply range. So this is how we can derive the equations. Now maximum range. So this is for the range. So now if I want maximum range, that is R maximum. So if you observe this expression, u is constant, g is constant, alpha can be varied. Here, if the maximum value of sin 2 alpha is 1, so you know that maximum value of sin and cos is 1. So therefore, what I can maximum range occurs when sin 2 alpha is equal to 1, or 2 alpha is equal to 90 degrees, or alpha is equal to 45 degrees. That means when the angle of projection is 45 degrees, you can have maximum range value, because u and g are constants. R will be maximum only if sin 2 alpha is maximum. The maximum value of sin 2 alpha is 1, or R you can write 2 alpha is equal to 90 degrees, and alpha is 45 degrees. So when you project the projectile at an angle of 45 degrees to the plane of projection, then you will be having the maximum value of range, or it is called as maximum range. So these are the expressions you can derive for a projectile motion. So main thing is you have to remember that in the case of a projectile motion, you will be having both horizontal motion as well as vertical motion. Horizontal component of velocity, you have to take u cos alpha. Vertical component of velocity, you have to take u sin alpha. For the horizontal motion, you have to take s is equal to distance travelled is equal to velocity into time. For the vertical motion, you have to take the motion against gravity. That is s is equal to ut minus half gt square, and v is equal to u minus gt, and v square is equal to u square minus 2gs. So those equations we have to consider for vertical motion. So using those we can derive the equation of trajectory of the projectile, which you are going to get as a parabola, because in the LHS y will be there, in the RHS x square term will be there, so which represents a parabola. Then using that, afterwards you can always find out the expressions for the horizontal range, maximum horizontal range, then time of flight, and time to reach maximum height, and the value of maximum height. So all those things we can always derive. So this is the general concept of a projectile. Now suppose if you want to find the angle of projection for a given required range, let us see what happens. So, your range, I want to project to have a required range value, then what is the angle of projection? That means, what I mean to say is, for a required or a known R value, what is the value of alpha? How to find the value of alpha? That is what the thing. So here we have the expression for R as we have derived just now. R is equal to U square sin 2 alpha by G. So this is what the expression just now we have derived. So from this, what is sin 2 alpha? Sin 2 alpha is R into G divided by U square. This is sin 2 alpha what we get. Now here R is fixed now. R is fixed. So according to this, what you can write here is sin 2 alpha. Here R is fixed. Even U is also fixed. So given R and U, G is also constant. So we can have two values of alpha, because it can be like this. Sin 2 alpha can also be written as sin 180 minus 2 alpha. In third quadrant also sin is positive. So if you use this concept here, so the one value of alpha will be alpha 1, which is alpha itself, because sin 2 alpha is equal to sin 2 alpha 1. If I write, you get alpha itself. Another value of alpha will be it will be 2 alpha 2 is equal to, I can write like this, 2 alpha 1 is equal to 2 alpha. That is one value of alpha, that is alpha itself. Another value will be 2 alpha 2 is equal to 180 minus 2 alpha, or alpha 2 is equal to 90 minus alpha. Alpha is equal to 90 minus alpha. Or I can write here that if you add this alpha 1 and alpha 2, alpha 1 plus alpha 2 is equal to 90. So that means the difference, what I can say, if you add these two, you are going to get alpha 1 plus alpha 2 is equal to 90 degrees. That means one value of alpha may be 45 plus theta, another value of alpha is 45 minus theta. So I can write like this. So if you will be having two values of alpha for a given range, if range is defined, if range is known, if you want to find the angle of flight, you will be having two values of angle of flight. So that you should be knowing. So for a one value will be alpha 1 will be equal to alpha plus 45 plus theta. 45 plus theta, another value is 45 minus theta, so that if you add these two, you are going to get 90 degrees. Theta will get cancelled, you are going to get 90 degrees. So this can be shown on a diagram like this. So here, please note that A and B, this distance is fixed. This is known, range is known. Range is known, and you have, if you project the projectile with 45 degrees, you are going to get the maximum height that I have shown. So if you are projecting this, if U is 45 degrees, if alpha is 45 degrees, then maximum height is reached. So this point C is reached. Now, if you have, if you know a definite, suppose this is R max, you can write here R max. This is maximum height. Now, if you want to reach at some other point, let us say D, AD is the given value of R. Starting point is this one only. So, if you project at an angle alpha 1 is 45 plus theta. So, this is 45. Plus theta means it will be somewhere here. So, I can write here. So I will just show you how to show that. So this is U, which is making an angle 45 degrees, for which we are getting maximum height. The other one will, other angle is 45 plus theta, which will be something like this. So like this. Okay. Another value is 40 this angle. So if you take, I will take this as u1, and this angle will be now alpha 1. So this alpha 1 is 45 plus theta. So the difference whatever is there between these two, that is theta. Next, the another angle will be 45 minus theta, less than 45. It will be something like this. See here. So this also will reach at this point only. So this is, I can take it as u2. The angle made by u2 is 45 minus theta. So this is 45 plus theta. This is 45 minus theta. This is 45 degrees. So this is how we can obtain, or graphically we can show the values of alpha 1 and alpha 2. For the same value of r, you can have two values of angle of projection in the form 45 plus theta and 45 minus theta. So if you add those two angles, you are going to get 90 degrees. For example, if alpha 1 is 30 degrees, then alpha 2 will be 60 degrees. So that theta will be 15 degrees, because alpha 1 is 60, alpha 2 is 30. So theta alpha 1 is 45 plus theta, alpha 2 is 45 minus theta. That means it is 60 degrees, it is 30 degrees. So this angle, the difference in the angle becomes 15 degrees there. So anyway, if they ask you to find the angle of projection for a given range, you will be having two values of angle of projection, alpha 1 and alpha 2.